What's up, Warriors? Coming to you early on a Saturday morning, raining outside, but I don't care. I'm here with the chicken, and what a better time to attack that evil thing, Pearson. So, yesterday I was working with some Warriors, and we had a question that just, I don't know, knocked me kind of silly. It happens. And so, like a good warrior, it bothered me for the rest of the day. It bothered me through the night. It's still bothering me, but more importantly, it bothers me because it's probably bothering you right now. Especially since right now, Pearson is down. It's been down from 1 in the morning. I mean, what worse time? Everybody loves to work on Pearson at 1 in the morning. Anyway, but it's been down, and it's going to be down till 9 o'clock, so I even can't get back in. All right, it's kind of like one of those little kids that like torments you and then runs away. Yeah. Anyway, we're coming back hard in a video on how to do that thing that kicked me in the rear yesterday. And the question was, we had some givens, so we had, it doesn't really matter, we had something like a population mean of 100 and a standard deviation of 10. Something like that, but it doesn't matter that these are exact because we know that Pearson has this evil way of making everyone have a unique problem. Okay, so the question was, there's a 65% chance that X is above what value? That's the question. Okay? And I know that the majority of us, including me, are kind of looking at this like a pig looking at a wristwatch. Like, huh? All right? Not that anybody's a pig, but just that, huh? Kind of like the RCA dog, on those old record, huh? Anyway. So how do you uncode this? How do you untangle this to do this problem and get the answer? Well, first of all, let's look at some fundamentals that we should not forget and always use. So what forest are we in? Okay, this name of the game, we need to know what kind of problem we're solving before we jump into the wrong forest and cut down the wrong tree. All right, and we are in the sampling forest. Okay, number one. This is a sample mean right there. It's not a single value, so we're not in a single value forest, and there's nowhere in this problem that's a confidence interval. You might want this to be a confidence interval because you see a percentage here, but that's not what that is. There's no words that say confidence interval. Okay? Right, chicken? Yeah, so we're good. Okay, and maybe you wanted, well, maybe this is a population proportion. No. When you see this boy, that tells you you're in the sampling forest. All right, good to go. Okay, what kind of tree am I cutting down? I am cutting down where I'm given. All right, let's do our givens in red since we already have these jokers in red. We're given a probability. And we are trying to find out what X bar is. So, okay, that is our unknown. So in terms of tree, we're cutting down where we have a probability, and we're trying to find out what X bar is. And to add on top of that, and really get down to the specific tree that we are cutting down, we're doing a more than. Is above. That's the cue yelling at us. Arch your back. Kind of thing. Above, more than. Above, more than. All right. Fundamentals. Okay, fundamentals. These and this thought process to think kind of meta will help you regardless of what the problem is. However, if you just jump into it and into the nuts and bolts and try to think of it that way, I just think that you are better off kind of framing this thing. You may think, oh, it's going to take me such a long time. No, 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 no. Slow is fast. Okay? All right? So, enough said on that. The next fundamental. Draw the picture. I say again. Draw the picture. This was the number one mistake that I made yesterday, and as a result, I wasted at least 3 warriors' time, and I'm making it up right now, trying to. So I draw that hack daddy. All right. I draw that mean. One hundo. Not to being confused with that emoji thing. That's so 100. All right. 65% chance that X bar is above what value? All right. So somewhere down on this axis, X bar is going to be. All right. Somewhere here. And a 65% chance that X bar is above what value? Well, let's just say that I put X bar here. All right. And then I want to figure out what this is going to be. Well, that's not going to be 65%. Okay? For this area that I'm trying to find out, that's got to be 65%. I've got to be to the left of the mean. So I have to go over here somewhere in order to get this to work. Okay? Because we know that this area is 50%. And so we need to go an additional 10% over here. And then this whole thing is going to be 65%. Okay? So, well, okay, so what? So I drew a little picture. That doesn't give me the answer. No, it doesn't, but it gets you on the road to the answer. A couple things we can glean from the picture. The big thing is that the z-score, is going to be negative. All right? It's going to be negative. And we need to, so it's going to be negative. I don't know exactly what it's going to be. I don't need to know, but it's going to be negative. Again, the second mistake that I made yesterday. I went jumping in the table looking for this. Okay? And I could, but I'd probably be better off looking for this. And more specifically, this. Okay? Well, you might say, well, why am I going to get that? That would tell me that right there in terms of a z-score. So, how would that work out? Well, because if I find this here, I'm going to find a negative z-score, and that'll work in my formula. Okay, so the bottom line is A, I draw my picture. B, I think about this. If I need to determine that, I actually need to go into the z-table looking for this. Okay, because my z-score is going to be negative. All right. Or I could go in another way. I don't know. There's probably another way to do this, but I'm going to go in looking for this and see what happens. Remember, I am looking for 0.3500. And so I'm in here like Mike TV, looking around, looking for 0.3500. So somewhere in between these dudes. Okay, so that is not it. That is not it. Okay, because I'm looking for 0.3500. All right, and so that's another one of these kind of like, I gotta stick it to you, Pearson does. Because what they want to do, and I think what you do here, okay, is you average. So if it fell on this one, we'd have a z-score of negative 0.39. And if it fell on this one, you'd have negative 0.38. So I think you take the average of these two if you feel it falls in between. But what we ended up doing was trying, I think, this one, because 385 would round up. So I'm going to go with a z-score of this, negative 0.39. So at this point, and definitely at this point in your arsenal, as you begin your prep, you can use stuff that I've put out, but I would really recommend at this point you make this your own. For this respective tree that we're cutting down, we know the chainsaw that we need. First of all, we're determining X bar. And we know the chainsaw we need is this one, Z times this right here, the standard deviation over the square root of n plus the mean is what we need. All right, so our givens, remember, were something like, I don't know, 100 and this. Okay, and let's just lay this out. Give myself a little bit more room. So X bar equals negative 0.39. And I forget what our n was. I think that n is 16. Okay? So, but again, it doesn't really matter. Okay? What matters most is the z-score that we found. And we put in 10 over the square root of 16, which is 4, plus that 100. Okay, so conceptually, let's think back to this and just kind of close a few of these loops. Remember, I said that we want to find the X value that goes, the X bar value that goes right there. And the mean, 100, is here. And so we went in there looking for the z-score that applies to this area. Okay? And that's going to be a negative z-score. All right? And we don't really need to do anything else once we do this math. And here's why. Okay? Let's look at this. That negative is going to make this whole value negative. And that's going to make X bar, this value, less than 100. Okay, without even doing the computations, I know that. because that times that is going to be a negative number. That whole negative number is going to bring that number down. Not like, hey, it's going to rain all day and you can't go outside anyway and you can't go to the movies and see your friends. Not like bringing you down like that. I mean bringing you down, meaning making it less than 100, which is what this diagram says it should be. Okay? So whatever it is, if it's 95 or whatever, that answer seems to make sense. Okay? That would answer the question that the 65% chance that X bar is above what value. So our answer would be a 65% chance that X bar is above 95. Okay, so that's how to do one of the tougher kind of problems, which is where you have a probability and you need to get either a single value X or a sample mean X bar. And that's a little bit on how to navigate that problem. Probably one of the tougher problems we're going to see. This isn't the only way to do it, but this is a way. Focus on the fundamentals, identify the forest you're in, and then start refining that particular tree and the formulas that go with it. That's fundamental set number one. Fundamental set number two is draw the picture. And I recommend that you practice these fundamentals in your reps between now and next Thursday so that it gets quicker. You may be frustrated and say, oh, it takes me so long to do one problem. Well, if you keep doing problems, it won't take you so long. All reps matter. All right? Have a great day. If you need help, send up the bat signal, and we'll talk to you soon. Chicken says see you. Take care.